One. Good morning, afternoon, and evening, everyone. Happy Monday and welcome to another Data Engineers Lunch. Actually, Data Engineers Lunch 83. Today we have a special guest speaker, Alex Merced, joining us once again. And today we'll be going over strategies for mitigation to Apache Iceberg. This event is run by myself and Raul. We are looking for speakers and sponsors, so if you're interested in either opportunity, please reach out to me at the email listed below. We are a part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is made up of a lot of different groups, generally surrounded around data, and you can find out more about all the various groups at the various sites listed below. What do we cover here? On our data engineers lunches, we cover everything from the ingress and egress of data and everything in between. We cover everything from databases, ETL, data wrangling, and all the tools and processes in the data engineering world. So if you're new here, please subscribe and join us every Monday, same time at 12 p.m. Eastern. If you're new, if it's your first time joining us here at the Data Engineer Lunch, please leave your name, how you found us, and what you're hoping to learn from these data engineer lunches in the YouTube comments. We do like to foster a community here, so go ahead and introduce yourself and what you're hoping to learn. Group rules, if you have a question, do ask it. Alex will be getting to his questions at the end of the presentation because there's a good chance he'll answer them as the presentation continues, but please do leave those questions in the chat and we'll get to them at the end of the presentation. Obviously, we ask you to be polite and courteous to others, and obviously we want you to share what you know with us. We want to make sure that we are fostering a community over here. And here at Anant, we build, manage, and we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. GW University helps us with space when we do host live events. It has been a while, but in the new year, do look for us to have some more of these our lunches in person. We also like to thank some of our program sponsors listed below, and some of our organizational sponsors as well. And I'd like to open the ground for any announcements you have, any jobs, meetups, hackathons, conferences, or classes. Please leave the information and links in the YouTube chat below. And we are hiring here at Anant. If you're interested in any of these opportunities or if you'd like more information on these, please visit our website and the link below. We do have our weekly events on Monday. We have our data engineering lunch. On Thursdays, we have our Apache Cassandra lunch. Do check our Anant US Flash events for a more detailed schedule of what we have coming up. And then finally, I'd like to point you to our new run book that we just released last week. This is the 11th edition, and this edition we go over copy commands and useful node tool commands as well. So do grab your free copy. I'll be dropping that in the YouTube chat as well. And with that, I'd like to hand it over to our presenter for today. Over to you, Alex.
Hey, everybody. My name is Alex Merced, and I am a developer advocate for Dremio. And today we're going to be talking about migrating to Apache Iceberg, because Apache Iceberg, you've probably heard of it by now. It's been sort of a big topic this year in particular. And so first thing we need to do is we're going to kind of cover like why that is, so that way we can understand why we would want to migrate to Apache Iceberg and how would we do that. But again, my name is Alex Merced. I'm a developer advocate here at Dremio, and you can follow me on Twitter at AMDataLakehouse. So again, follow me on Twitter, add me on LinkedIn. I'm constantly posting all sorts of video, audio, written content about data lakes and data lake houses, a lot of it revolving around Apache Iceberg. So if you find the topic interesting, do make sure to follow me. But again, we'll be talking about Iceberg structure. So just to kind of remember, like, the why, like, yes, we want to migrate to Apache Iceberg, but what is Apache Iceberg giving us? What catalog to use, because you've decided, let's say you decide I want to migrate my data to Apache Iceberg, you're going to need a catalog. We'll discuss what a catalog is during the structure piece, but which catalog should you use? We'll discuss that right afterwards. Then we'll discuss different ways to migrate, which includes the migrate procedure, the add files procedure, and using create table as statements. As all possible options with different pros and cons, different use cases. So we'll kind of discuss that. And then a little summary, a little best practices there at the end. Okay, so Apache Iceberg. So what is Apache Iceberg is it is a data lake table format. So the overarching idea is this. Right now in the status quo world, you have your sort of OLTP data sources that your application is generating a lot of data. You're generating data in other aspects of all your business lines. And then generally what's going to happen is you're going to take all that data coming from all these different places, generally ETL them to generally like the universal dumping ground, which is the data lake. And then from the data lake, you'll ETL a subset of that data to your data warehouse. But this results in a lot of things like a lot of data copies, which results in kind of difficulties with, maintaining regulatory compliance, data drift, and trying to see like, hey, are we using a consistent definition of our data when you have all these different copies that are being transformed in different places? Then you have the additional cost because you're doing that additional ETL job to ETL the data into the data warehouse, which results in more storage and compute costs for that ETL work. And so forth and so forth. So there's all these different reasons why it'd be nice to reduce the footprint of the data warehouse. But up till now, a lot of the things that the data warehouse does weren't really easy or possible on the data lake. But with the sort of new modern data table formats, you can do that because what they do is they provide this layer of metadata that query engines and other data lake tools can use to look at your data lake, whether you're storing a bunch of files on Hadoop in a Hadoop cluster, where you're storing a bunch of data on object storage on AWS, Azure, Google Cloud. Wherever the data is stored, this metadata layer allows those tools to be able to look at all that data as if we were looking at a database, where the data is actually organized into different tables, and you can operate in those tables using SQL. So it gives you that data warehouse feel, and allows the guarantees and consistency of working with your traditional database data warehouse, but on your data lake. So now you don't have to have two, you can have one, and reduce costs, maintain that regulatory compliance because you're not having to like search for scattered data copies all over the place. And it just makes the whole architecture simpler and more cost effective. Okay, or at least that's the promise. So basically what Apache Iceberg is going to provide these things. And the way Apache Iceberg does it is it basically takes that metadata and stretches it across 3 different layers. So generally every Iceberg table has metadata files, which sort of define the table as a whole. So it's like, what is the schema of the table? What is the partitioning of the table? What are the different snapshots of the table? That would be at the metadata file level. Then there's your manifest lists, which are generally snapshot level. They define an individual snapshot of the table. Okay, but each snapshot is made up of different files, and those files are grouped together in what's called a manifest. So each snapshot is generally a group of different groups of files, aka manifests, and then essentially that's how we track the different versions of the table. So every time the table changes, a new snapshot is created, and each snapshot defines which groups of files are included in that snapshot. And because it's broken up that way, you get a lot of reuse because that same manifest can be used in multiple snapshots, basically making it much simpler to make each snapshot sort of isolated, self-included. Like I don't have to go back and read all the previous snapshots to be able to read this snapshot, but you're not necessarily creating like a humongous amount of files because they're going to reuse those manifests when necessary. So it gives you this really nice structure that allows for a lot of really cool, efficient query patterns when an engine actually reads the table. So it gives you performance along with all those features that normally would only exist on a data warehouse, like time travel, asset transactions, things like that, all on your data lake. So kind of the recap, the way this all works generally is that Apache Iceberg, one of the big things that it does is that it decouples from the old way of doing things, the Hive way of doing things worked, where everything was based on files in a directory. Okay, so in the Hive world, essentially you have a folder and all the files in that folder are considered part of the table. Okay, so basically it really heavily relied on all the files being in the same folder. And generally other table formats like Apache Hudi, like Delta Lake also kind of depend on that structure in the sense that they're saying, okay, hey, this folder is my table and the files have to be in that folder. Apache Iceberg sort of decouples from that. Instead, the files can be anywhere long as the metadata knows where they are. Okay, so in order to kind of make that possible, the way we track what tables exist is we use a catalog. Okay, so generally there's going to be some sort of mechanism that acts as a catalog. Think of it as like the phone book for the table, basically saying, okay, the metadata for this table is over here, the metadata for this table is over here, and basically the metadata will then tell me where the files are. Okay, and that metadata, that catalog, you could be using just like the file system. That'd be an HDFS catalog. You could be using a Hive metastore. You could be using a open source project called Project Nessie, which actually has a special catalog. It's designed specifically for this purpose. And the great thing about the Nessie catalog is it allows like branching and merging. So it allows you like Git-like semantics, so that way you can like branch your catalog and then merge those changes, which enables things like multi-table transactions. Very, very cool stuff. But essentially what would happen is that a query engine is going to look at that catalog and be like, okay, this is where this table is, which will then point it to the metadata file for that table. So now we know what that table's definition is, which then points it to the whatever snapshot you're looking to query, which is represented by the manifest list. And then that manifest list will list all the groups of files, all the manifests that make up that table. And at each layer, a query engine can then like filter out files and filter out groups of files. So that way you're not scanning every file for every query, just the files you need, whether it's through partitioning, min-max filtering, and other strategies that Iceberg enables. Okay, and to kind of get the full detail on how that whole process works, a few months ago here at the Data Engineers Launch, I did talk about the structure of an Apache Iceberg table, so I would recommend checking out that talk to get the more details of how that whole pattern works. But again, the way we track what tables exist in your Apache Iceberg world is through the catalog. So basically what you choose as the catalog matters a lot because it's going to be sort of the center of your Apache Iceberg world. Every query engine to get access to all your tables needs to connect to the catalog. And then that's how they'll know these tables exist. Okay, so whether you're connecting via Spark, Dremio, whatever tool you want, the catalog is going to be what tells it, hey, these are the tables that are around. Okay, and there are several that you can use, not just the ones I have listed here. But again, there's Project Nessie, as I mentioned earlier. This one is unique because it was actually designed to act as the catalog. So a lot of the other ones were things that existed for other purposes, but can be used as a catalog. Project Nessie was designed to be used as a catalog, particularly for like data lake tables. And one of the big features that Project Nessie provides is that you get this Git-like functionality. Okay, so you can merge, branch, which is really good for like isolating different like ETL work, doing multi-table transactions, things like that. And another nice aspect of Project Nessie is that you don't necessarily have to set up a whole new server. You could actually get a cloud managed version of Nessie through a Dremio's Arctic service. So that we literally just a couple clicks of a button, you have a catalog. Your Spark jobs can connect to that catalog. Your Flink jobs can connect to that catalog. Literally any engine can connect, any catalog or any engine that has built-in Nessie functionality, which is most, will be able to connect to that catalog. Okay. Again, one of the cons is that not every engine necessarily have support, but you do have support. Spark, Dremio, Flink. I'm pretty sure Presto has Nessie functionality now. So you have a lot of options as far as what can connect to this particular catalog. Okay, but if you're not using the cloud service Arctic, you would then have to deploy your own Nessie server, kind of like you would deploy like a Hive metastore. So that's really cool if you want that additional functionality. And again, that offers you a lot of really cool, again, pros, especially with like a lot of that isolation. So if you understand the benefit of Git, then imagine that on your tables where you can actually just branch your catalog, make a bunch of changes, and then merge those changes in. So that way people see all the changes at the same time instead of seeing the changes incrementally. Hive metastore. Okay, now this is a good choice if you already have a Hive metastore that you're using in your data infrastructure, because then you can just use the metastore that you already have that's running. Okay, so that minimizes a lot of the work because you already have the thing going. If you don't have an existing Hive metastore that you're already using, then that would be the con, that you'd have to set it up. But essentially, it would allow you to track your tables. Generally, you would use this if you already have it. Then there's AWS Glue. Okay, AWS Glue is great as a catalog, especially if you're using AWS services. So if you're working with like AWS Athena, if you're using AWS Glue and AWS EMR, all of those services work really well with the AWS Glue catalog. So it's going to give them pretty much easy visibility into your Apache Iceberg tables if you're really using the AWS ecosystem. Okay, but if you're going outside of the AWS ecosystem, you do have support with like AWS, Spark, Dremio. Like there's a lot of engines that do connect to the AWS catalog. But let's say you're using like the Azure ecosystem or the Google Cloud ecosystem, then you may not necessarily have as much ability to connect to the AWS Glue catalog. In that case, you may prefer to opt for like Project Nessie or Hive Metastore. There are other options. You could use like DynamoDB as a catalog. You can use like any JDBC database, like a Postgres or MySQL database as a catalog. So you have lots of options. And they're constantly like expanding. So now they actually created like a new REST catalog, which allows you to kind of create a REST API on top of like any kind of pretty much any mechanism. So you can create like custom implementations for your catalog. So yeah, basically that's generally the first thing. So before we actually think about migrating the data, the first thing we have to do is like, how are we going to track the tables? Like what catalog are we going to use? Because we need to make sure that the tools that we're using, so what engines are we using to query our data, we want to make sure that they work with the catalog that we're going to use. Okay, which one's going to have sort of the best features for our particular set of technologies. So again, if you're heavy into the AWS ecosystem, then AWS Glue makes a lot of sense. If you're not tied into any particular ecosystem and just really want the full-on feature set, then Project Nessie is very compelling. It just depends on sort of like what your situation is, what's your use case. Okay, we'll talk more about the register table method in a moment. But when you're migrating the Iceberg, you have to think about like, hey, where does my data exist? And there's going to generally be two approaches to how you can do this. You can either rewrite the data, and that's another nice thing about Iceberg, because all the files don't have to be in the same folder, you don't have to rewrite all the data. Okay. Generally with like other table formats, you have to rewrite the data so that way it is kind of in that single directory structure. So you may or may not necessarily be able to reuse the files that you already have that exist. With Apache Iceberg, you can opt to not rewrite the files. If you have a table that's in Hive or Delta Lake or something like that, where all the data is stored in Parquet, you can just take those same existing Parquet files and add them to an existing Apache Iceberg table, which then saves you the time of having to rewrite all those files, a lot less compute, a much smoother migration initially. But you also have the option of rewriting the data using like a CTAS statement. Okay, so that's generally going to be the two paths, the two options you have. So always the question is, if you want to not rewrite files, the big question is just going to be like, is my data already in Parquet? If it is, then that's very much an option. Okay, so assuming you have existing Parquet files that are part of a Hive table. So this specific method I'm about to talk about is for Hive tables. So you have an existing Hive table built through Apache Hive, but all the files are stored in Parquet. So if it's not stored in, if the underlying files are not Parquet files, then this you would want to then convert it to Parquet files. But Apache Iceberg has a migrate procedure built into it. And this migrate procedure allows you to take any Hive table, assuming that it's built on top of Parquet files, and just basically turn it into an Apache Iceberg table. Basically, you just flip a switch. It just basically creates a new table and then writes the metadata that all those existing files that belong to that pre-existing table are now this Apache Iceberg table. So literally all you're doing is you're writing some metadata, not rewriting. So if you have like a 5 terabyte table, okay, you're not having to rewrite 5 terabytes of data. You're just rewriting the metadata so that way those five terabytes can be accessed through the Apache Iceberg query process, which is very, very nice. Okay, but keep in mind that when you do that, it does kind of kill the previous Hive table. Okay, but generally you would use like basically in the Apache Iceberg Spark extension. So this would be something you'd be doing through Apache Spark. You have these call procedures. So so basically the actual call would look something like this. So you would have your catalog that you've already configured with Spark. Okay, and so that could be a Nessie catalog, a Hive catalog, an AWS Glue catalog, and you would call this migrate procedure, and then you would put the name of the database in there, or the name of the other table in there. So basically what would happen is you would have your Hive catalog configured and your Iceberg catalog configured in the same Spark session, and then you would just run this and say, okay, hey, this catalog needs to migrate this table. It just migrates it. It's done. now it's in your Iceberg catalog. You can query it going forward. Okay, but generally best practice is that before you do that, because again, migrate kills the original table. Before you do that, what you want to do is run the snapshot procedure. What this does is more of a temporary test version of it. So it kind of does the same thing, except it creates a read-only Iceberg table because it doesn't kill the previous Hive table. It's just going to say, okay, this is what it would look like. Query it, play with it, test it out, make sure that everything kind of moved over the way you expect it to. And if everything looks good, then you can go back and actually do the migrate. Okay, but this way you can make sure that like the end result looks good before you fully commit to it. Okay, and so that's what the snapshot procedure does. Very similar call procedure. You would just call on your catalog and just say, okay, hey, I want to make a snapshot of this table. We're going to call the new table, this. And then you can then experiment. But this right now only works with Hive. There is a pull request where they're creating an implementation of the migrate procedure that will work with Delta Lake tables. So in the future, you should be able to possibly do this with Delta Lake tables as well. So that way you could actually migrate a Delta Lake table and through this sort of simple process. But there are ways to move that data from like a Delta Lake table or any other type of table if the data files are in Parquet, and that's called the add files procedure. Okay, so if they're not a Hive, if it's not a Hive table, well, it actually really doesn't matter what style the table's in, long as the underlying files are Parquet. If that's the case, then there's a procedure built into in the Spark extensions called add files. Now, what this add files procedure does is a little bit different. So what you're doing is you're not taking one table and converting it into a new table. What you would do is you would first create an Iceberg table with the right schema. And then what you would do is you'd say, hey, I have all these Parquet files here, which could be the directory with your Delta Lake table or the directory with your Hive table. You just point it to where the Parquet files are, and you say, I want these files to be part of this Iceberg table. And then it'll write the metadata so that way those particular Parquet files are now considered part of that Iceberg table. So again, you're not rewriting any files. So you're talking, you could be moving over petabytes of data without having to rewrite any of it. And now you have it in, you get all the benefits of Apache Iceberg. Okay, so this could be, again, and the table could be, those Parquet files could be coming from any style of table because they're just Parquet files. Now, one note, if you're talking about like Delta Lake, is that with like Delta Lake, again, you might have multiple snapshots of the table in that folder. So if you sit there and say, hey, add all these files to this Iceberg table, you might be adding files across many snapshots to the table at the same time, which is not necessarily what you're trying to do. So typically what you'd want to do if you're making that migration, you'd want to expire all your previous snapshots and then run the vacuum command on Delta Lake so that way it cleans up all those files for all the previous snapshots. So that way the only Parquet files that are in that directory should be to the current state of the table. So that way when you run this add files procedure, you're only adding the files for what the table is currently. Okay, so that's what you can, one way you can do migrate a Delta Lake table now without having to rewrite all the files. Okay, cool. And again, any directory of Parquet files you can do this with. All that matters is that the schema of the Iceberg table matches the schema of the Parquet files. And then you can add them and they're now part of the table. And again, you're not rewriting any data files, you're just writing new metadata, which is a lot less intensive an operation. Okay, but the thing about it is that sometimes you may want to rewrite the data. A lot of times you do want to rewrite the data. Why? Because you may have had this Hive table, this Delta Lake table, this Postgres table that you've had partitioned in a particular way for a long time. Some of the field names may not be what you want them to be. And you're like, well, if I'm going to migrate this table, let me make some of these changes I've been meaning to make anyways. Maybe I want to rename these few fields. I want to add a few fields. I want to change the way it's partitioned. Okay, you can't do that in the previous way because you have to keep things the way they are when you don't restate the data. So when you use migrate, add files, everything kind of works the way it's been working. But when you do like a CTAS statement, a create table as statement, you can then take advantage of, hey, I'm going to rewrite these 5, terabytes of data. But hey, while I'm doing it, I'm going to change the way it's partitioned. I'm going to rename those fields and take care of some of that additional work you were thinking about doing anyways, and then rewrite the table the way you would have ideally liked it. And this you can do with pretty much any engine. So this isn't currently only in Spark. You can do create table as statements in like Spark with Dremio. And the cool thing about like using Dremio for this is that Dremio makes it really easy to connect to all sorts of sources. So you can easily connect Delta Lake tables, easily connect like a Postgres database and several other sources. And then generally any source you can connect to Dremio, you can then CTAS into an Iceberg table. And then soon, Dremio will have some other features that will allow you more other options when it comes to migrating into an Iceberg table. So keep an eye out for that. Okay. But this would just be an example. You would just run a create table statement and see in this case, I'm going to change the way it's partitioned. And this cool thing here is I can take advantage of some of the special partitioning features that Iceberg has, where I can just kind of identify, hey, I want to break this up into 16 buckets. Hey, I want to partition it by days in this field. Okay, I want to partition based on the truncated value of this field. I can take advantage of those at that point, and it will rewrite the data with that partitioning in mind. So in this case, I am rewriting the data, but the end result can be, partitioned in a much better way. Again, I can change my field names, change field types, so that way, the new version of the table has anything that I would have liked to have fixed in the past fixed. Okay, so again, you got lots of options. Migrate, are the data files rewritten? No. Okay, again, that's nice because it's going to be a lot less compute because you're not rewriting all these files. But you can't update the schema or partitioning when you do that. You're just taking the files as they are. But if it's migrate, you're just taking the table as it is and the way it's partitioned from the Hive table and just moving it over to an Iceberg table. Right now, that can only be done with a Hive table. Okay, although there is, again, a pull request that might add additional implementations of that for different table types. There's the add files procedure, which allows you to take Parquet files, directly add them to an existing Iceberg table. Doesn't matter where those Parquet files are from. So if they were written for a Delta Lake table, written for a Hive table, it doesn't really matter. You're just taking those files and saying, hey, it's part of this table now. So are those data files rewritten? No, it just adds, because again, all Iceberg cares about is that it knows where the file is located. It doesn't have to be in the same folder with everything else. So long as it knows the file path to that file, it can be written down in the metadata and it knows, okay, that's where the file is when I need it. Again, and that's very unique to Iceberg, where again, it's not dependent on the directory structure of the table to be able to know what belongs in the table, which is why it can let you do this kind of migration where you don't have to rewrite the files. Okay, in other formats where it is dependent on the directory structure, that becomes a little bit more tricky. You are having to write more stuff because you've got to make sure the stuff is in the right directory. Okay, and again, you can move basically, you can take any existing table with the files in Parquet and use this add files procedure to add those Parquet files to Iceberg. Okay, Iceberg technically also supports Avro and ORC as far as data files go. So technically, they could be ORC or Avro files. But the only question I would ask there then, if you decide you want to save some of your data in Avro or ORC, is then again making sure that whatever engines you're using to query Iceberg, do they also allow you to read the ORC and Avro files that are inside that Apache Iceberg table? Because Iceberg supports it, but it doesn't necessarily mean every engine that reads Iceberg supports that. Parquet is pretty ubiquitous, so you shouldn't have a problem with that. And then there's a CTAS approach. When you do the CTAS, you are going to rewrite all the files. But the benefit is you can update the schema, you can update the partitioning in the middle of this process. And this works for a table from anywhere. Okay, so basically, long as you can connect the original source and your Iceberg catalog to the same session with the engine, whether it's Dremio, whether it's Spark, whether it's some other engine, a CTAS statement will allow you to move from point A to point B. So again, with Dremio, you would just connect like a Postgres database and to say CTAS, that Postgres table is not an Iceberg table. Same thing with the Delta Lake tables, same thing with the MySQL tables, same thing with any source you can connect. Okay. Now, one other thing I want to talk about, which has been now it's been there for a while because 0.14, now we're like, I think they just released 1.01 today or 1.1 today for Iceberg. So some new features have just been released today. But back when they released 0.14 a little while ago, a couple months ago, they added this register table procedure. This is pretty cool because another migration issue you might run into. So right now we've talked mainly about, hey, you're migrating from not Iceberg to Iceberg, and then you have to choose a catalog. And the catalog you may have chosen, maybe you chose Hive because you had a Hive metastore, okay? But maybe a few months down the road, you're like, that whole like branching and merging thing of my tables, that sounds actually pretty cool. Maybe I should do that. So then you want to go use a Nessie catalog or a Dremio Arctic catalog. And now you want to move all your tables from this catalog to that catalog. Of course, you could always do a CTAS. That's fine. Problem with the CTAS is you do lose like all those previous snapshots, which is not, maybe you want to have those previous snapshots. So what you can do is you can use register table. What the register table method does is that essentially you would do this like through like Java. I think you can do it in Python, or you can even just do it from Spark. But basically, what you do is you would instantiate a catalog that represents your new catalog. And then what you would do is you would say, hey, I want to register this table with this catalog. And what you're passing it is the file path to the metadata file. So remember those 3 tiers of metadata: metadata files, manifest lists, manifests. So you say, hey, this manifest file, this metadata file, that's the table that I want. And then your catalog will then create a new table entry that points to that metadata file. But because you're using the metadata file, you're not writing a new one. It's going to maintain that snapshot history and still have access to all the other files in every state of the table that existed beforehand. But when you do that, when you migrate from one Iceberg catalog to another, you generally don't do it like backwards. You're not saying, hey, now I have it registered with 2 catalogs, which theoretically it could be. It's still in the previous catalog, and now it's registered in the new catalog. You don't want to be doing like they're still thought of as 2 separate tables. So for example, if I were to do like an update transaction in the new catalog going forward, it does create a new metadata file in that catalog, and that new metadata file will still have the snapshot history. But again, the other catalog, the previous catalog, isn't aware of that update. So it's still pointing to the older metadata file. So, that's the reason why they created the REST catalog, because that way, if you did want to have like multiple catalogs, you could create like a API. You could use the REST catalog functionality to create sort of an API layer. So that way you can do like updates to multiple catalogs at the same time. That's a newer thing. I don't think anyone's implemented that yet. But that's sort of one of the reasons why that's a thing. So that way, if you did want to work with multiple catalogs, there is a path to that. But just registering your table with another catalog doesn't mean you can use both. So basically, I would think about it as a migration action. I'm moving from this catalog to that catalog, and that's my catalog going forward. That's the way I would think about it. Yeah. So basically, those are your different sort of migration scenarios when it comes to Iceberg. So you're either migrating from not Iceberg to Iceberg, which are these first 3 scenarios, or you're migrating from Iceberg catalog to Iceberg catalog, which is when we start thinking about the register table procedure. Okay. Now, when it comes to best practices, you're doing this migration. Okay, what you want to do is you're going to want to kind of not just say, hey, I'm going to flip a switch and my tables are now Iceberg tables. You want to do it incrementally. And you're going to want to write all your current workloads in a way that incrementally do the shift. So generally, like think about it as you're going to have this 4-phase plan. So in the beginning, what's going to happen is that you have your status quo, where you're currently all your consumers' reads go to that original table. So that original Hive table, that original Delta Lake table, and all your writes are going to that original table. You're going to move from that to the second phase, where all your reads are still going to go to the original table, because again, this is an incremental migration. But now anytime you write, you've created a new table. So you've created the new Iceberg table. So you might have the Iceberg table alongside the Hive or alongside the Delta Lake table. And every time there's a write, you're writing to both of them, because the goal right now is to make sure that they're in sync. And you want to make sure you run those tests to make sure that they are sort of in sync, so that way you can eventually just pull the plug on the old table. Then what's going to happen is that you move into the next phase once you kind of know that they're in sync and all those writes are keeping pace. And then what you do is you shift the way the read queries come in. So any reads coming in now will go read the new Iceberg table. Okay, you still write to both tables because you still, you want to make sure you test everything before you completely pull the plug on the old table. But once everything looks good, like all the read queries are coming in just fine, they're getting the results, all the writes to the Iceberg table are working, everything is going well, and you feel comfortable just calling it a day with the old table and getting rid of all that, storage space and additional commute from having to have that table, you just go back to just working with the Iceberg table alone. Okay, and so the idea is that, you know, it's not an overnight migration. You want to kind of have a plan where you kind of walk through these steps and you have mechanisms to go through these steps, especially when you're talking about like migrating a lot of data. Another thing to consider is that you don't have to migrate all your data overnight. Okay, the great thing about tools like Dremio, or really just using any catalog with Iceberg, is that you can migrate, you know, a handful of tables, see how it goes, and then as you know everyone gets more comfortable working with Iceberg, you can keep migrating more and more tables, and expanding sort of the Iceberg footprint, because it's not like if you're using Spark, if you're using Dremio, if you're using Presto, you have to use Iceberg only. Iceberg, you know, you could be a start off with a small footprint that you keep expanding as you get more comfortable and you begin seeing the value in many of the features that Iceberg brings to the table. Okay, and this just kind of summarizes what I just said. Okay, but essentially that would be sort of the thought process in the migration. With that, and again, just one last summary. Again, basically, when it comes to migration to Iceberg, first thing you need to think about, what is your catalog? Once you kind of think about what your catalog is and you've made that decision, okay, then the question is going to be like, how do I want to migrate my tables? By restating the data using a CTAS, or by not restating the data through the add files or migrate procedure? And then I would come up with like my 4-phase plan to execute that transition, depending on how large scale of migration you're trying to pull off. But with that, I will start looking into the chat for questions. So let me go, or I will open it up to questions wherever they're coming from. Okay. So any questions? I am all ears. But one other thing to keep in mind while I see if any questions come in, I also just want to make sure you guys are aware, if you want to learn more about Apache Iceberg, I do have this article over there at dremio.com/subsurface. It is Apache Iceberg 101 article. And this will have, basically has a long video series where I kind of go through many of the Apache Iceberg features. Okay, and then basically it's also a big digest of a lot of the greatest Apache Iceberg articles and tutorials from around the web. So literally pretty much any kind of use case or thing you're trying to find some more information on Apache Iceberg, you can probably find it organized on here. Constantly adding more hands-on type tutorials. Okay, so if you've never used Iceberg before, there's a couple of good introduction icebergs where you can get hands-on with like a Spark in a Docker container. So you don't have to worry about spinning up any kind of clusters or incurring any cloud costs to actually try these things out. So you can find all that here again at dremio.com/subsurface. Just check out this Apache Iceberg 101 article. But again, with that, I open it up to any Q&A.
It doesn't look like we've had any other questions come in. Yeah, it doesn't look like we have any questions come in. But Alex, I'd like to thank you again for another fantastic talk. Appreciate you getting on. I look forward to more talks in the future. I'd like to thank everybody else for joining, starting off your week with us. We appreciate it. We'll see you guys at the same place, same time next week. If you haven't already, please make sure you get that new run book. And if it's your first time here, please subscribe to the channel.